Hi, welcome to NPTEL course on combinatorics. So this is the fourth week problem solving session for this course. So I am Prakash Joshi, a third year PhD. So today we will solve uh, some problems related to problems uh, which the structure taught in this week. So let's start. Let me share my screen and the problems. Okay, okay. So let's start. So recall. So in this week we started with Young's diagram or Ferris diagram of partition of natural number. By using this, we also prove the recurrence relation for the partitions of natural number. Then what we have done after this? After this, we goes to principle of inclusion and exclusion. Principle of inclusion and exclusion. After this, what we have done? So this is so what is the principle of inclusion and exclusion? Let me write the statement. So statement, what is the statement of this one? Let X be a finite set and A1, A2, so on, An be subsets of X. Then then the okay. So X be a finite set and A1, A2, An be subsets of X. Then what we would like to ask, so we would like to ask is that what is the number of elements which are not in any of AIs? So then number of elements which lies in none of the AIs is what? So what is this? This is defined as this we have proved in lectures. This is minus 1 to the power cardinality of I times cardinality of AI, where I is subset of 0, 1, I should say 1 to n, and I is any subset of 1 to n. Yes. So I is subset of 1 to n, and I can be empty as well. And A5 is your full space X, and AI is equals to intersection of I belongs to I, AI. So this is the statement of this principle and of inclusion and exclusion. So by using this, we have computed many things in lectures. So one of the example is number of surjective functions from a given set to from an n cardinality set to k cardinality set. We have computed that by using this principle of inclusion and exclusion. So the basic case for this principle of inclusion and exclusion is two cardinality case, we already know like A1 number of element in A1 union A2 is A1 plus A2 minus A1 intersection A2. So then we generalize this by using principle of inclusion and exclusion. So, and what next? What we did after this? So what we did after this in this week? So we did principle of inclusion, number of surjections, then okay. So we did 12 fold ways. What are these basically? So 12 fold ways is basically you have n balls. We have some balls and some boxes. You want to place them. Like you can put conditions like balls are labeled or boxes are labeled or both are labeled and on none of them labeled. These are four conditions. Then you can put a condition that like each box contain at least one ball, each box contain at most one ball, each box there is no such condition on a box can contain all ball or none ball, so there is no such condition. So these there are 12 such cases, so these are 12 fold ways. We have done this in class, and then after this what we have done, so we have also done partial ordered set, partial partial ordered set. And so what is a partially ordered set? So a set, so a set, what is a partially ordered set? A set P equipped with a relation which is symmetric, sorry, anti-symmetric, reflexive, and transitive. Good. So a partially ordered set is a set equipped with a relation which is reflexive, anti-symmetric, and transitive. So by I hope the terms are clear. So what is a reflexive means? Reflexive means X is for any. Okay. So let me write. Relation is, let's denote the relation by this symbol. So a set P equipped with a relation. So reflexive means what? Reflexive means X is less than X for all X in P. Anti-symmetric means X is less than Y, and Y is less than X means implies X is equals to Y. And transitive means X less than Y and Y less than Z implies X less than Z. So these are uh, some definitions. So any two elements are said to be comparable, then if X is less than Y or Y is less than X. So so maximal Hn is a Hn is is uh, is a sub poset of a given set in which all the elements are comparable. So if if all the maximal chains, if all the maximal chains chains in a poset are of same size, then then poset is said to be graded of rank n. Poset is said to be graded of rank n. Good. So these are the basic thing. Same size and same length, I should say, because this is in the definition. Same length n, which is the n. So to be graded of rank n. Good. So let's start with problems. So
Hello.
here is the first problem. So this is the quick recall of theory. So now start with the problem.
Hello.
Yes, yes. Is there anyone? Question. So find the number of five tuples S1, S2, S5 contained in this notation. You already know this 5 means 1, 2, 3, 4, 5 set, basically containing 1, 2, 3, 4, 5, containing 5 cross 5 cross 5, 5 times basically, such that union I equals to 1 to 5 Si is full set 5. So what are the number of these 5 tuples? We have to ask. So have you understood the question or not? First of First tell me that whether you understand the meaning of question or not, what he's asking. Then we can try to approach. Are you getting or not?
Oh, so each of the S1 can be a number in the set. What is S1 is a
No, no,
single
no.
digit, right?
These are subset. This notation is not elements. This is not belongs to. This is subset. I already write subset. So that means each SI is a subset of this 1, 2 up to 5 set basically. So the question should write SI should subset of this set 1, 2, 3, 4, 5, which is denoted as this one. So each SI is a subset of this one.
Okay.
Now the condition is that their union should be full set. So can you think how to proceed to such questions?
So it should be
If he asks for
factorial.
single element, then it is more or less easy. If he asks for single element, then it is not difficult. Can you see that?
So it's the set is five tuples, so it is ordered. And if you have that
Yes.
SI union is
Yes.
five, so it's basically a
So you
string of length five of so five factorial. No.
yes, that is correct. Yeah, that is correct. If it is numbers, basically elements of the set. But here he are asking subset. So can you think something? There is only one participant or someone other than you, because only you are responding. Is my voice breaking? I saw the message voice is breaking. Hello.
Sir, your voice is breaking in between.
Okay, fine. Let's so is it working fine now? Hello.
Yes, sir.
Okay. So okay, hope it will work fine now. So let's start with this problem. So can you give some idea for this? How to proceed? What is your idea? What you are thinking?
Sir, can you give a example of a member of example of such a five tuple?
Yes. So let me give you example. So let's choose S1 is equals to 1, 2. S2 is equals to 1, 2. S3 is equals to 1, 3. S4 is equals to 1,
Okay,
4.
okay. Yes, I
S5 is
understand
equals
now.
to,
There was a I had a confusion. Yes, I understand now.
yes. Okay. So can you think something now? Okay. So let me give you some more hint. Then maybe you get something. Okay. So given union of I is equals to 1 to 5, Si is full set. So that means for any x belongs to this one set, this implies x belongs to union I equals to 1 to 5 Si. So this implies x belongs to Si for some I. Okay. So I feel that this hint should be sufficient for you to answer this question. So so any element should be in sum of Si. So can you see something? Let me construct something more for you. So you can construct as
So
Tx
it is similar
of
to
in
the case with
yes,
distributing
yes,
balls with at least one or more
I,
balls.
yes,
So
yes,
this.
yes. Some I all cases there in 12-fold ways. So yeah, can you think now? What is this Tx possible? What is the possible size for Tx? What is the cardinality of Tx? Can you see something? Let's start with one. T1. T1 is collection of I such that one belongs to Si. So cardinality of T1 can be what? It can be empty set, right? T1. Okay. So basically, these indices are subset of 1, 2, 3, 4 up to 5 because we have S1, S2, S3, S5, right? So cardinality of T1s are basically it can be I can be just one, I can be 1, 2, I can be 1, 3, 1, 2, 3, all possible, but it cannot be that, right? Are you getting this on?
Yeah. Yes.
Hello.
Sir, so here so if say one is in two sets, 1 and 3, so that is written in only one way,
Hmm.
or we care about 3, 1 and 1, 3.
We do not care this wording, but we care about this only. Like so suppose I gave you already such composition that S1 is 1, 2, S2 is 1, 2, something like that. So S3 is 1, 3, something like this, you right? S4 is 1, 4, S5 is 1, 5. So in that case, one is basically set 1, 2, 4, 5 because this is built to each SI. I get it?
Yes, yes, I get it. So cardinality of any element, we have bounds but not exact, right? Because the one element has to be at least in one of them to make up the union, the full set.
Yes, but we can exactly just say the cardinality. Why you are saying maximum bound? For each tuple we can create this thing. Why you are saying maximum?
No, I'm saying minimum at least one.
Yeah, at least that is correct. That is, this set will be non-empty. This is clear because the union is SI.
Yes.
But we have to say the number of five of this form where union. So
So,
as the posture
sorry,
of this SI
your
so
voice is breaking up.
oh so okay. So let me so we have to say that how many tuples we have for of such five sets S2, S2, S3, S4, S5, right? Hello, hello,
Yes, sir.
hello. Is it working now?
Yes, I can hear you now, but it was getting all broken off.
Uh, okay. So let me go outside and sit outside. Maybe that will work. Okay. So is it fine now? Is
Yes,
it
sir.
fine now?
Yes, sir.
Okay. So I am sitting outside now because I am not in campus. So currently I'm in my home. So it is located in hill area. So here is connectivity issue. So let's start. So I have already proceeded, right? So 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 I gave you this thing. So we have constructed this set. Can you hear me now, Abhishek? Or is it still breaking?
It's breaking up intermittently. It's not stable, I suppose.
Okay, so let me change my connection. Wait a second. Abhishek, hello.
Yes,
Is it working now or is still it is same issue?
right now it's working.
Okay, so fine. So okay, good. Let's proceed. So we have given this thing, right? So we have constructed this. So similarly, okay, let me write and then you can ask me your doubts, whatever doubt you have. So we can similarly construct T2. T2 is collection of indices J such that one belongs to Sj. So similarly, T3, T4, T5, K such that phi belongs to Sk. Right. So if we know this T1, T2, T3, T4, T5, so we precisely know this Si basically. What are the possible choices Si? Because if we know T1, we know one belong to which set. If we know T2, we know one belong to which Sj. If we know T3, we know one. Okay, I should write two. So if we know T3, we know three belong to which possible set. Okay, so in this way, know each of SIs. You are getting me, me or not. So if we say the cardinality of each of TIs, so what are the possible cardinality of TI basically? We have to find number of five tuples. So what are the number of five tuples? So what is the cardinality of T1? So cardinality of T1, what can be possible cardinality of T1? T1 can be non-empty any set, right? T1 can be non-empty any set. So cardinality of T1 is 2 to the power 5 minus 1. So that is 31, right? So similarly, that is same as cardinality of T2. That is same as cardinality of T3. That is same as cardinality of T4. That is same as cardinality of T5. So that means, so that means, so how many is such number of five tuples we have? So since, okay, let me write. Since each each determined by Ti. So, so required number of tuples of the form S5 is equals to 31 into 31 into 31 into 31 5 times. So this is your answer. So you can compute it. This will be some larger number. Is it clear, Abhishek?
Yes, I understand.
Or any doubt? You are asking initially something, right? What is your doubt?
Oh,
You can
yes,
ask me.
I have misunderstood the fact that we are only counting all the possibilities. So I
Yes,
was just
yes.
taking some exact possibility. So that was why I was getting caught up.
So you are saying that's why it is only it can be only one case.
Yeah,
You are
yeah,
saying, right?
yeah.
So is it clear now?
Yes, yes, it's clear now.
Okay, okay, fine. So now change. Now let's do the same question, but the change the condition. The condition how what? Okay. So the condition is this thing. So question is same. So second question. So we want to determine same number of five tuples and S1, S2, S3, S4, S5 such that union of I equals to 1 to 5 Si is full set. Not condition on union, but condition on what? Condition on their let's such that S1 is contained in S2, is contained in S3, is contained in S4, is contained in S5. Okay. So now can you say how to proceed for this question? Huh. Can you proceed now? Hello. Am I audible? Am I audible? Or there is some issue? It's breaking. Hello. Abhishek, can you hear me?
Hello. Yes, I can hear you now.
Am I
Yes, I can hear you.
okay? So is it breaking again now? Or
Uh,
it's fine?
it's yes, it's breaking up now.
Okay, so what I can do, I don't know. So okay. So can you say something about this question? Hello. Hello. Hello, am I audible? Hello, hello. Okay. So in my we five the form of this form S5. So that S1 is contained in S2, contained in S3, is contained in S3, is contained in S5. Okay. So so, so uh, N1 is so N1 be smallest number I such that 1 belongs to Si and 2. So this means what? So if 1 belongs to Si, that means 1 belongs to, let's suppose I is equals to 3. So that means if 1 belongs to S3, that means 1 also belongs to S4, 1 also belongs to S5. So example, here you can understand. Example, if I is equals to 3, so this means what? 1 belongs to S3 implies 1 belongs to S3, S4, S5, right? Similarly, N2, N2 is smallest number. Similarly, okay, so Nj, I should say, the smallest number I such that J belongs to S, Si. So if we define in this way, so what are the possible choices for N1? The possible number Nj can be Nj can be 0 because there can be case like one may be the case that each SI is empty and one is none in that case one is none of SI. So there may be similar other cases. So in that case, Nj can be 0, Nj can be 1, Nj can be 2, it can be up to 5, anything. So right. So if we know each Ni, then it is clear that we know S1, S2, S3, S4, S5 because we know in which set 1 belong, in which set 2 belong, in which set 3 belong. So right. So this is one-to-one correspondence. So clearly choice of Nj's determine clearly choice of NGS determine SIs uniquely correspondence is 1 to 1. So this implies, so what this implies, so so each n1 has six choices, n2 has six choices. So this implies, total number of required choices is equals to, on first slot we have six choices, on second slot six, up to how many times? Five times. So this is 7776, I guess, something. So is it clear? Abhishek, can you hear me?
Yes, sir.
So is this part clear or not? Are you able to follow, or the voice is breaking again? So I will upload the PDF as well, recorded lecture. If there will be some audio issues, I will be re-record this lecture and you can see on YouTube as well. So on YouTube, this recorded lecture, I will modify if there is some audio issue on recorded part. So you can follow it there if here you are facing some issues. So let's go ahead. So next problem. So question, the infinite summation over k 2 to the power minus k over all positive integers k that are not divisible by 2 and 3. The infinite sum over all positive integer k that are not divisible by 2 and 3 is. So, so we have to determine this summation 2 to the power minus k over all positive integer k that are not divisible by 2 and 3. Okay. So any idea how to proceed? So we can use principle of inclusion and exclusion, right? By
Yes.
using, okay. So can you say how to proceed? By using principle of inclusion and exclusion, what we can write? Inclusion, required summation, required sum is equals to what? First we do full summation, then we subtract what we, okay. So first we do full summation, k is 1 to infinity, full summation of 1 by 2 to the power k. Then what we do, we remove the part which we need to remove, like we need to remove the choices of k for which are divisible by 2 and divisible by 3. So we remove the choices which are divisible by 2, which are the form 2 to the power 2k. We remove the choices which are divisible by 3. These are of the form 2 to the power 3k. And then, but we remove these choices twice, which are divisible by 2 and 3 both. So we have to add plus 1 upon 2 to the power 3k. Sorry, 6k. So we have to compute this summation, right? So how to compute this? So this is easy. This is basic geometric progression series which you have read in 9th, 10th class. So 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 this is, let's open this sum so that you can see. Put k equals 1, then you will get 1 minus 1 by 2 square minus 1 by 2 cube plus 1 by 2 square minus 1 by 2 to the power 4 minus 1 by 2 to the power 6 plus 1 by 2 to the power 12 plus 1 by 2 to the power 3 minus 1 by 2 to the power 6 minus 1 by 2 to the power 9 plus 1 by 2 to the power 80. So so on you have similar summation. So this is basically so this is so let's do, this is a GP, this one, this is again a GP, this is again a GP, this is again a GP, right? So you can do the summation. So sum of a GP, so you take 1 by 2 common out, then sum of this will be, so this will be a GP of the form 1 plus 1 by 2 plus 1 by 2 square plus so on. Similarly, in second term, you take 1 by 2 square common out. So this will be of the GP of the form 1 plus 1 by 2 square plus 1 by so on. Similarly, on third term, you take 1 by 2 cube common out. So this will be of the form 1 plus 1 by 2 cube, 1 by 2 to the power 6, 1 by 2 to the power 6, 1 plus 1 by 2 to the power 6 plus 1 by 2 to the power 12 plus so on so on. So this is just calculation now. So you can compute this. So what is the sum of GP? 1 upon 1 minus R. R is 1 by 2 in first case. So this is 1 minus 1 by 2. This is 1 by 2 square into 1 by 1 minus 1 by 2 square minus 1 by 2 cube, 1 minus 1 by 2 cube minus, sorry, plus 1 by 2 to the power 6, 1 by 1 minus 1 by 2 to the power 6. So you just compute it, what you get. So first term is 2 is cancelled with 2. So this is 1 minus, so 2 square will be cancelled with 2 square. So this is 1 by 3. So this is 2 cube will be cancelled with 2 cube. This is 1 by 7. And this will be 63, right? 1 by 63. So this will be 64 by 63 minus 7 minus 3 minus 10 by 21. So you compute it. So you will get 63, 64 minus 30. So this will be what? This will be 34 by 63. So I hope it is clear. Is it clear?
Yes, sir.
So yeah, is voice still breaking or is it fine?
Yes, actually.
Okay, fine. So next problem. So find the number of permutation of number of permutations of the 26 letters A, B, Y, Z that do not contain pattern John, Paul, and Smith. I should write everything in capital because I write initially in capital, so I should write in capital. John, so yes, can you say something for this question? How to proceed? Can you say something?
Principle of inclusion exclusion.
So yeah, Abhishek, you are saying something.
Sir,
Hmm?
principle of
Yeah.
inclusion exclusion. First, we so for the each of the so we first subtract all the permutations containing John, then Paul, then
Okay.
Smith,
So
then
so
their intersections, unions. I suppose intersection, not union.
okay. So what are your choices for sets on which you are using the principle of inclusion and exclusion? You need to determine this set A1, A2, A3, like that, na? Hello.
Sir,
Okay. Huh. You are saying something?
the whole set is 26 factorial size of the
Huh.
whole set. So we
Okay.
subtract from that first. Uh, uh, we have fixed four of the letters. So John.
Okay.
So we have
Okay. Okay. Okay.
we
I
have
got your idea. So you are fixing A1 to be patterns which contain the okay, which do not contain okay. We want to determine do not contain the pattern John. So which contain the pattern John? So you are saying permutation. So you are using in this way, I guess. Permutation containing pattern John, right? So
yes.
that's what you. Then similarly A2 permutation containing pattern is what is this Paul? And then A3 is permutation containing pattern Smith. So then you are directly using the formula only. Okay, I got you right. So tell me what you are saying. So this is basically what A1 what we need to determine A1 complement intersection A2 complement intersection A3 complement which lies in none of the given set. So that is what the principle of inclusion exclusion. So what is that? Summation over all possible set minus 1 to the power cardinality of I into cardinality of AI. So yes. So when I is empty set, so in that case full set and its cardinality is 26 factorial, full, all permutation on 26 symbols. Then you are removing a cardinality of A1. What is the cardinality of A1? Can you say? What is the cardinality of A1? You have four word fix and remaining 22 can be anything, but these four word you can treat as a one word. So you you have permutation on how many symbols? 23 symbols, right? 23 factorial. Similarly, same for Paul and same for Smith. Now, what is the cardinality of A1 intersection A2? So you have how many symbols? Eight symbols, right? John is also in fixed in pattern, and Paul is also in fixed in pattern. But John you can treat as a one word, and Paul you can treat as a word. So so you need to remove 20, so you have 20 choices, right? So 20 factorial. So equals to cardinality of A2 is equals to cardinality of A3. So cardinality of A1 intersection A2 is 20. Cardinality of A2 intersection A3 is how much? 5 words, 4 words. So 7, we need to remove 17. So 19 factorial. And what is cardinality of A1 intersection A3? Can you say this? A1 intersection A3? Can you say what is the cardinality of A1 intersection A3? So this will be 0, since in a permutation H cannot be repeated. So that means this plus minus 0. So you can compute this number. What is this? So this will be the required solution. So is it clear?
Yes, sir.
So you got why this A1 intersection A3 is 0 or not? If not, you can ask me.
Yes, sir. Because it will not be repeated actually.
Yeah, we cannot repeat the one alphabet basically, guys, in a permutation. Yes. So next question. Assume the numbers 1 to 500, 1, 2, 3, so on, 500. The first part is saying how many of them are not divisible by 7. Second one is saying how many of them are not divisible by all 3, 5, 7. C is saying how many of them are not divisible by 7? How many of them are not divisible by 7 but divisible by 3, 5? So can you try to answer how to do first part? So you have given a set which is numbers up to 500, 1, 2, 3 up to 500. So first part is asking how many of them are not divisible by 7. Would you like to answer? Okay. So let's do this. So let AI be the set of integers between 1 to 500 divisible by I. So we want to find A7 complement, right? So we want to find cardinality of A7 complement. So part A is asking for cardinality of A7 complement. So what is this? This is cardinality of full set minus cardinality of A7. What is cardinality of A7? Numbers which are divisible by 7. So this is greatest integer function of 500 by 7. So this is what? This is uh, 7 7 ja 49 and 7 1 ja 7, 70, right? So this is 429. Is it clear? First part.
Yes, sir, I wrote in the chat because of some network issues.
Okay, fine, fine, fine. I'm unable to see chat because I'm sharing the screen, so I didn't see the chat. Okay. So now the second part is asking how many of them are not divisible by all 3, 5, and 7. So how to do this? So what we want to find out? We want to find out numbers which are not divisible by 3, not divisible by 5, and not divisible by 7. So what? So we want to find out.
So
It should be
similarly,
lie in.
we'll do in this case.
Yes, yes. We will do similarly, but how? Can you say? A3. We want. What is this basically? How many of them are not divisible by all 3, 5, and 7? So it should, a number n is in this side basically, n should not be divisible by 3, also should not be divisible by 5, also should not be divisible by 7. So that means this is what basically this number should lie in the complement of A3, also in complement of A5, also in complement of A7. So this number lies in this set. So we want to find out the cardinality of this set. So what is this thing? So now just use the formula what you know, principle of inclusion and exclusion basically. So this is what cardinality of full set
Sir, does the
minus
question say all or any?
by all.
So then it should be that it's simultaneously na 3, 5, and 7. If it
Uh,
were any of the 3, 5, and 7, then we would do this.
so you are saying we should count what? So you are saying uh, how many of them are not divisible by all 357? So he is saying how many of them are not divisible by all 357? So it should not be divisible by 3. It should not be divisible by all. All means all these three numbers basically 3, 5, and 7, right?
So yeah, so you basically get 3 times 5 times 7.
Yes. But these are divisible by these numbers. So we want to count out. Yes, you are correct. So these are basically 3, 5, 7. Yes. So which are divisible of the form 3 into 5 into 7, correct? Of the form 3, 5, 7k. So you can do in that way, right? So just count its complement. So you are saying you are correct, I guess. What you are saying. So you are saying that x is your basically 3.5.7k numbers of the form 3.5.7k.
Yes, yes.
So what is the cardinality of this set basically? So x is basically n such that n is of the form 3.5.7k and n is less than equals 500. So what is the cardinality of x? You have to compute cardinality of x complement, right? So you have to find out this thing. So what is this?
So suppose only 4 numbers.
Huh. So you are saying cardinality of x is only 4?
Yes, sir. Because it's simply after 4 it crosses over 500.
Okay, what is this number 357? So this is 5 3 is a
So
15, 15.
357 times 5 goes to 5 to 5.
Okay,
So you can only have up to 4, right?
so this is 105k, right? So this is only 4 times. So we have only 4 choices, correct? K can be what? K can be, yes, K can be
1, 2, 3, 4.
Yes, k can be 1, 2, 3, 4. That is correct. So cardinality of x is 4. So you are saying, so the cardinality of required cardinality is basically what? 500 minus 4. So that should be, you are correct. I am thinking in this wrong way, right? This should be 496, you are saying, right?
Yes, sir.
This should be correct. So what I am doing, so I am computing A1 complement, which lies in A3 complement means which are not divisible by 3, which lies in A5 complement means which are not divisible by 5, A7 complements which are not divisible by 7. So I'm taking all their intersection. So which are not divisible by 3, 5, 7. So this way also should be same, right? They should give same answer. Abhishek, is it clear?
Yes, yes, yes.
They are same basically. A3 complement is numbers which are not divisible by 3. A5 complement is numbers which are not divisible by 5. A7 complement is number which are not divisible by 7. So I'm taking their intersection.
Yes, yes, yes.
So this should be same thing.
Yeah,
So
yeah.
but the answer are
Yes, sir, it will
not
be
matching.
same.
But the answer are not matching. So that's why I have doubt. So we have did something wrong in this Abhishek argument.
So, actually, what I was initially saying is that because that implies that we have an OR relation and versus we have an AND relation.
Huh. But where this is wrong, I am not getting. So have you got where you are wrong in this argument? Because the answer should not be this one. In at least in the argument, what I am saying, I'm just using principle of inclusion and exclusion. Then you can just put on the formula basically. So this is 500 minus what? The cardinality of A3. So what is the cardinality of A3? You can say 500 divided by 3, greatest integer function. Then similarly, this is 500, 5 greatest integer function. This is 500, 7 greatest integer function. So then plus 500, 3.5 greatest integer plus 500, 5.7 greatest integer plus 500, 3.7 greatest integer minus 500, 3.7.5 greatest integer. So can you compute it quickly? Like I just want to check the answer whether my calculations are wrong or the answers are not matching. Just compute it quickly. I'm also doing. So this is what. So so what is this number? So are they same or not? 500 minus 166 minus 100 minus 71 minus 33 minus 14 minus 23 plus 4. So this is coming out 97. Is there any calculation mistake? Hmm?
Sir, it should be more now because you have change the signs in the second equality. You have like all of the
Ah,
three
oh,
minuses,
oh,
you should have it
mm,
plus.
yes, yes, yes. It will be bigger number, somewhat bigger.
So even then,
Yeah.
it's a lot bigger. So the approaches don't match.
So why this is happening? They should match now. So what you are computing only this thing, right?
Sir,
You are computing
are
only
you
last
actually
combination.
computing A3 complement? You are computing A3 actually.
No, A3 I computed in sorry, A7 I computed in first part. But why you are saying I am computing A3?
So see, A3 complement is all the numbers that are not divisible, right?
That are not divisible by 3.
Yes. So if you have, for example, in the so
A3 complement will be basically this thing, na? A3 complement is 500 minus cardinality of A3. So cardinality of A3 will be 500 minus 500 greatest integer function of this thing. So this is what? 3 1 ja 3, 6, 166. So this will be somewhat this number.
we
So
have
where is this?
shouldn't we have that in the first three parts? So 500 minus 500 by 3, 500 minus 500 by 5.
Why? This is just a formula, na? कि वो number of element which does not lies in any of AI basically which lies in the complement of each of AI. So that is basically summation of I subset of 1 2 3 minus 1 to the power cardinality of I
Are you
into
writing as a complement of the first one?
huh? Huh? What you are saying?
A3 complement intersection. So are you taking the complement of the whole thing?
No, I'm taking first complement then intersection.
I think we have our sets wrong. We should have
Why?
if in the
What is
in
your
the
set basically? What is your set? You first take the numbers which are divisible by 3, which are divisible by 5, which are divisible by 7, right?
hmm,
Ah, I got it. Both are different things.
both are
Both
different.
are different. Both, yeah. But the question is asking this one, right? What I am computing, I guess. Not divisible by 3. Oh, sorry. Question is asking what you are saying, right?
Yes, it's saying all, but even in the formula A3 complement
Huh,
intersection. So
huh,
if you write it in the straightforward way, so what is it? A3 complement plus A5 complement plus A7 complement minus
hmm,
the what intersection of A3 complement to A3 5 complement. Similarly for the rest two terms, and
huh.
then
Yeah, that will match what you are saying. Yes, you are correct. Just write simply without using this formula. Just write simply what you are including, then exclude that, then include. That will be same thing. So this number is 229. But the question is asking, I guess, different thing. What Abhishek is pointing out. So he's correct, and I am wrong at this point. So let me write what he's saying. So we have to compute numbers which are not divisible by each of 3, 5, and 7. So that means B part is saying, uh, I have to not say it B, I have to say it star. B part is saying numbers which are 3 complement, which are not divisible by all three can be divisible by any two of them. That will be E3 uh, intersection A5 intersection A7 का complement. So that will be 500 minus 500 choose 357. So this will be what is pointed out 496. So yeah, so first one is saying the computation which we did first is saying that numbers which are not divisible by neither divisible by 3, neither divisible by 5, or divisible by 7. And the computation Abhishek was saying that numbers which are not divisible by all three. So they can be divisible by two of them, but not not all three divides them. So this is the computation. Abhishek is saying that question is pointing out this thing, but I was initially thinking that question is pointing out this one, but I have written. So whatever is correct. So this is the solution. So yeah, so yeah. So let's go third part. So how many of them are not divisible by 7 but divisible by 3 and 5? So how to compute this one? So you have to compute what? A3 what not divisible by A7 complement A3 intersection A5 intersection A7 complement. You have to compute this one, right? How to compute this? Same thing you can do same calculation, right? Am I audible?
Yes, sir.
Okay. So you can see how to do this same calculation basically. So you have to do cardinality of A3 plus cardinality of A5 plus cardinality of A7 complement. Then subtract cardinality of A3 intersection A5 minus cardinality of A3 intersection A7 complement minus cardinality of A5 intersection A7 complement plus add all things. So you can do the computation, na? Maybe the another easy way can be this, right? The first part we have computed A7 complement, and in this computation we have computed numbers which are not divisible by 3, not divisible by 5, not divisible by 7, right? So, so yeah, this is clear from A and star. So this is also clear from A and star. So from also from also from A and star, also from A and star, but number of integers that are divisible that are divisible by 3, 5, but not divisible by 7 is first part minus this second part computation, right? So that is 429 minus 229, that is 200. Yes. So is it clear?
Yes.
Okay. The question: so give a combinatorial proof of the following identity. N minus R choose M minus R is equals minus 1 to the power k 20 minus, sorry, I should say, right, N minus k. We need to prove that N minus R choose M minus R is this summation, which is on right hand side running over k minus 1 to the power k R choose k into N minus k choose M. So how to prove? So we will give a combinatorial proof to this. So let's start. So here this. Okay. So what is this left hand side in is denoting? So this is basically left hand side side denotes computing m element subset of n cardinality set and of n set such that r elements are fixed there, which are already there. Thus, subset n denote computing m element subset of n set such that the elements a1, a2, so on, so on, are already there in subset. So this is precisely this n minus r choose. So n minus r. And what is right hand side? But this can be counted. This can be counted by PIE, principle of inclusion exclusion, as follows. So suppose n greater than equals k, denotes number of m element subset of element subset which does not contain which does not contain k element from the set k element from the set from the set A1, A2. So these are so the left hand side is precisely its complement. These are m element subset which lies in complement of these m element subset. So this is the idea. And by principle of inclusion and exclusion, we know this is precisely then by principle of inclusion and exclusion, this is equal to, it does not contain, by principle of inclusion and exclusion, LHS is equal to summation k is running from 0 to r minus 1 choose k. Then you have to choose k element out of r elements, which are always A1, A2, AR. Then among n minus k element, you choose m element, right? Because these k elements are already not there. Yeah. So thus n minus r choose n minus r is equals to summation k is running from 0 to r minus 1 choose k, r choose k, n minus k choose n minus k, right? So this is one. Okay. So let's consider the next problem. Okay. So this question is asking, so let n bigger than equals to and a be the set 1 to up to n. Then the question is asking how many permutations a1, a2, an of set a are there. Then how many permutations a1, a2, an of set a are there such that ak comma ak plus 1 does not equals j comma j plus 1 for any k is in n minus 1 and for any j in this set. So two consecutive terms should not be same. So we have to count permutation on n symbols such that two consecutive AJ and AJ plus 1, AK and AK plus 1 are not JJ plus 1, right? This is what we have to count. So we will consider its complement set and then use the principle of inclusion and exclusion. This is the simple idea we always use to solve such kind of problem. So let's do this. Okay. So let's start. So this is standard notation, SN, set of all permutation of 20 of 20. Let's suppose so what we have up to n minus 1, right? K belongs to n minus 1, J belongs to n. Okay. So let's suppose we define AJ as sigma belongs to S such that such that j plus 1 immediately comes after j plus 1 immediately comes after j, right? So j belongs to 1, 2, up to n minus 2, right? So what is the cardinality of AJ? So you have all possible permutation, but only one condition that j and j plus 1 should come together. So once you are fixing the position of j, you have to fix the position of j plus 1. So that means you have exactly n minus 1 factorial, right? Because there is only one restriction on the position of j plus 1, nothing more than that. N minus 1 factorial. So what is the cardinality of AJ intersection AK? So, so on AJ, you are fixing one J, and AK, you are fixing another K, and K plus 1 should be adjacent. So you have two restriction precise. So this is minus 2 factorial, right? Similarly, so on AJ intersection AK intersection AF is n minus 3 factorial. Continue in this way. So now you can use principle of inclusion and exclusion. So now by using principle of inclusion and exclusion, what we can say, exclusion, number of required permutations, number of required permutations is equals to cardinality of is basically S minus complement of this thing, A1 union A2 union En minus 1. This is precisely what by principle of inclusion and exclusion. This thing, right? First, we have to choose K among these n minus 1, and then the cardinality of that set is n minus k factorial. Cardinality of A1, like you are choosing case K first, then A1 intersection A2 intersection AK has cardinality n minus k, right? So yeah, that is precisely the principle of inclusion and exclusion. So now you can just solve this and you can get. So what you can do, just take n minus 1 factorial common out. So first term will be n, and what are the next terms? N minus 1 factorial is always going to appear there. No? So n minus 1 factorial, what is this? Let's suppose k equals to 1. So that will be minus n minus 1 choose 1. So that is n minus 1 choose 1. That is n minus 1 factorial will be common out from here, and this is precisely n minus 1. N minus 1 choose 1. N minus 1 factorial by 1 factorial into n minus 1. So this will be n minus 1, right? So by 1 factorial. Similarly, 2 to, then we will get n minus 2 by 2 factorial. and minus 2 by 2 factorial. Then n minus 3 by 3 factorial plus 1 minus 1 to the power n minus 1 by n minus 1 factorial. This will be your, can you put k equals to n. If you put k equals to n minus 1, so minus 1 to the power n minus 1, n minus 1 to n minus 1 is 1, then n minus. This is above n minus 1 factorial. This should be 1 I guess. This I am writing incorrect, I guess, right? Because you take n factorial common out, so n minus 1 factorial is there. So yeah, 1 upon this will be when you are putting k equals to n minus 1, this will be 1 factorial and n minus this is 1. So 1. So this is 1 by n factorial in denominator. 1 by n factorial is denominator. And then something is 1 by n factorial I guess. K equals to 1 equals to 3 everything. N minus 1 factorial is same. So let's see. Sorry, we have taken n minus 1 factorial common, so that is fine. So this will be 1 by n minus 1 factorial. That is correct. Yes. So yeah, this is the required thing. This is the required number we need, right? We need to count the number of permutations such that two consecutive terms are not fixed. So this is the requirement of such permutations. So let's do one last problem, then we will stop. Okay. Let f be the set of all functions from this 11 cardinality set to 0. Let's consider the Poset. This I am defining this. Let me define this. Where function f plus than g if and only f x plus than equals gx for all x in this 11, 1 to up to 11, right? So, so, so this is asking, question is asking, is f with this ordering is a graded Poset or not? If yes, what is the term? So I already recalled the definition initially. So if the maximal chain is of same length, then it is said to be graded Poset, and the length of maximal chain is said to be its rank. So yes, so let's solve out this. So capital F is set of all functions, right? So let's write with this one. What is capital F? Capital F is F such that F mapping 11 to 0, 1. This set, right? F is in this set. So we have given the ordering of this function, right? And any function here can take value either 0 and 1. So you want to start with a chain, right? So first you can take the 0 function, right? So let's take f naught equals to 0 function, taking all values 0. Here you start with the f naught, that is a 0 function. Then what you can do, you can fix one function, you can make one function f1, 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 taking value f1 x is equals to 0, yeah 1. If x does not equals to 11, if x equals to 11. So this will likely above here, since fx is f1x is always greater than. So this is clear. So f1x is greater than because f naught x. Similarly, you can make a chain, right? f2x is equals to 0 if x does not equals to 11, 10 and 1 if x is equals to 11, so this will basically contain this. So similarly, so on you can make this up to f11x, which is 1 for all x belongs to this way, right? Now you can make some other change, like I started with 11, you can start with some arbitrary element, but that every maximal chain you can extend up to length 11, because any function you will give, that will give take value 0 at some point and 1 at some point. So this will lie somewhere in between this chain. So you can make this chain is maximal. So let me write in a similar way. There are many possible such chains, such maximal chains, but each chain, each maximal chain each maximal chain has length 11 if there is any function, say gx, say gx, then gx will take value 1 at some points and 0 at other points. So that will lie in a maximal chain obtained in above the. So, so what? So given Poset is graded of rank 11. Yes. So this is what we want to do today. So with this, I will stop here. If you have any doubt.